All right, we're going to go and take a look at the Gay-Lussac's law problems. So for these ones here, we're using the equation P1T2 equals P2T1. So P1T2 equals P2T1. All right, let's look at the first one, number one. We have a volume, we have temperature, and we have pressure, and we're given temperature, and we're given pressure. So if we're looking at this equation, we don't need the volume here, so we're going to ignore that. All right, let's write out what we know. So this is collected at 22 Celsius and 1 atm. This is the first bit, so we'll call this 1 and 1. It increases to 35, and this is the new pressure. We'll call this 2 and 2. So T1 is our temperature, 22 degrees Celsius. Our P1 is the pressure. We have 0.98. Sorry, let me make sure. Sorry, guys. Today is not my day. All right, let's get this back in frame. Okay, we are, so again, 22 degrees Celsius, that was T1. P1 is 0.98 atmosphere. Our temperature T2 is 35 degrees Celsius. And then we're solving for P2, which is going to be our unknown. We want to change this to Kelvin, so we're going to add 273 to each of these to make this Kelvin. So we should get 298 Kelvin, and here we get a total of 308 Kelvin. So we have our pressure, we have our temperature, this is ATM, and we're going to solve for this. So we are looking for P1 T2 equals P2 T1. We are solving for our unknown. We don't know what the new pressure is, so we're solving for P2. So we're going to divide both sides by T1. So that goes away. So we get P2 equals P1 T2 over T1. All right, let's plug in what we know. We know that the pressure one is 0.98 atmosphere. So 0.98 times temperature 2, which we know is 308, over our temperature 1, which is going to be 298. So when we solve for this, we're going to do 0.98 times 308 divided by 298. So we should get a pressure of 1.01 atm. All right. So second one's going to be really similar to this. Again, we have pressure, temperature, temperature, trying to find pressure. So pressure 1, temperature 2, pressure 2. All right, so we were writing this out, T1, P1, T2, P2. Our temperature is 20 plus 273. This will give us Kelvin. Our pressure is 2.2 atmosphere. Our temperature 2, we know it drops to 15 degrees. So we'll add 273 to give us Kelvin. And then the last one, we don't know what it is. All right, so we should get 298 Kelvin, 2.2 atmosphere. This would be 285 Kelvin. And then we don't know what pressure 2 is. So we're solving again, P1 T2 equals P2 T1. We're looking for P2, so we're going to get this one by itself. And we'll divide both these by T1. All right, to get this one by itself, we're going to rearrange this. So P2 is equal to P1 T2 over T1. And then we can plug in what we know. So P2 is our 2.2 times the T2, which is 285, divided by our T1, which is going to be 298. So we multiply these two out and we divide by the bottom. So 2.2 times 285 divided by 2.2 times 285 divided by 298. So we're going to get pressure 2 of 2.10 atm. All right, and then for 3, we'll set up 3 and then kind of solve the same way. So again, pressure, temperature, pressure, temperature. What is the pressure? We know this is P1, this is T1, this is T2, this is P2. So again, P1 equals 760 mmHg. Our T1 is the temperature, so 25 degrees Celsius. We're going to add 273, so we get 298 Kelvin. Our pressure 2 is going to be our unknown. We don't know what that is. And then our temperature 2 is going to be our 50 degrees Celsius plus 273. So when we add these two together, we're going to get 323 Kelvin. So to solve for this, P1 T2 equals P2 T1, and then we just replace. So 760. Let's just rearrange this first. We're looking for P2. We solved that here, so we're just going to write P2 is P1 T2 over T1, because it's the same thing that we found up here. All right, pressure 2 is going to be equal to 760 times our T2, which is 323, divided by our 298. So we're going to divide this out. 760 times 323 divided by 298. So we're going to get our answer for this is going to be 823.76, and that's going to be mmHg. All right. Okay, last bit for number 4. As pressure increases, temperature should do what? So according to Gay-Lussac's law, so when pressure goes up, our temperature goes up. When pressure goes down, temperature goes down. So as pressure increases, temperature should also increase. We call this a direct relationship. So this would be an example of Gay-Lussac's law. All right, and then that's it.